For the beam shown, beam ABC is supporting beam CD. We are tasked to find the reaction at C, reaction at D, and the value of X if the reaction at B is 380 newtons. So first, let's draw our free body diagram of these parts. We have a pin at A that will induce a vertical and horizontal reaction. Let's call this AY and AX. And B is known to have a value of 380 newtons. And a general roller at C and a pin at D, which would resist a vertical and horizontal reaction. Let's call this dx and dy. To begin our analysis, we can start analyzing the free body diagram of beam ABC or CD. So I will choose analyzing the free body diagram of force CD, though you can choose ABC. So beam CD has a reaction, a force of 120 kilonewtons at the free end, and a roller that is a distance of 2 meters from the 120 kilonewton force, and a triangular load that has a height of 30 newton per meters and a width of 12 meters. That has a reaction of dy and dx, and this one is, let's call this cy. To solve for cy, we're going to take summation moments at point D equal to 0, considering counterclockwise to be positive. To do this, it would be wise to convert this triangular load into its resultant force acting at the center of the triangle. So the resultant force is equal to the area of the triangular load. That is equal to 1/2 times base times its height of 30 newton per meter. So the resultant is equal to 180 newton. And it is acting at a distance of 1/3 of the distance of the base of the triangle, that is 12 meters divided by 3, so this is equal to 4 meters. And this one right here is equal to 2/3 of 12 meters, which is equal to 8 meters. Now we can proceed solving for the reaction at Cy. So summation moment at point D, we have a 180 Newton force going counterclockwise, so it's positive, times the moment arm distance of 4 meters, plus the 120 Newton force times the moment arm distance of 14 meters, minus the clockwise moment of Cy times 12 meters, equal to 0. Now we can solve for Cy, that is 180 times 4 plus 120 times 14 minus 12 times Cy equal to 0. We get Cy is equal to 200 Newton. That is a letter D. Also solve for dy and dx with the summation force vertical and horizontal. Since there are no horizontal external force on this beam, therefore dx is automatically equal to 0, and to solve for dy with the summation force vertical equal to 0. So we have dy plus cy, that is 200 Newton, minus the downward force 120 minus 180 equal to 0. And we can solve for dy, that is equal to negative 200 plus 120 plus 180. We should get the value of, that is 200 negative plus 120 plus 180. So dy is equal to 100 Newton. That is at letter C. Now we can proceed analyzing beam ABC to solve the third problem. We have a horizontal and vertical force of AX and AY in the left side, and a 600 Newton force acting X distance, which we need to solve, and a roller support B that has a value of 380 newtons acting 10 meters from the left support, and a 120, no wait, this 120 Newton force is from beam CD. So we can proceed this is the internal roller at C that has a value of, we solved earlier, that is 200 Newton. So to solve for the value of X, for this to maintain in equilibrium, we can take moment at point A to solve for X. So taking summation moment at point A equal to 0, considering counterclockwise to be positive, we have negative 600 that would induce a clockwise moment times the moment arm distance of x plus the 380 Newton force that would induce a counterclockwise moment times the moment arm distance of 10 meters minus the 200 Newton force times the moment arm distance of, this is 3 meters, so the moment arm distance is 13 meters, all equal to 0. And we can now solve for x by using our calculator. This is 600, negative 600 times x plus 380 times 10 minus 200 times 13, all equal to 0. If solved, we get x is equal to 2 meters. And that is letter C and D.